So, fluids are substances that have their shape easily modified under the action of their own weight. They have two main properties, density and viscosity, which will directly affect the ability of a fluid to erode and transport sediments. The density of the fluid is defined as mass per unit volume of the fluid, referred to as ρ. Density affects the magnitude of the forces acting on a fluid and on the surface where the flow occurs. Density also affects the rate at which particles fall or settle through a fluid, where particles within denser fluids will have lower settling rates. For instance, because water is denser than air, water will be able to transport coarser sediments than air will. Now, density is different from viscosity, which is just a measure of the ability of fluids to flow, where fluids with lower viscosity flow readily and fluids with higher viscosity flow slowly. For example, air has low viscosity relative to ice, and water has low viscosity relative to honey. This is important for us because viscosity plays a key role in the turbulence of water, as we'll see next. Now, if we want to determine if a flow is turbulent or laminar, we use the Reynolds number. This number is a parameter developed by Osborne Reynolds in the late 19th century. It is a number that represents a quantity without dimensions relating three factors: the flow velocity, the kinetic viscosity of the fluid, which is the ratio of fluid viscosity to fluid density, and a characteristic length L, which may be the diameter of a barrel or the depth of a flow in an open channel. Now, the flow is considered laminar when the Reynolds number is low, lower than 500, and turbulent when it's high, higher than 2000. Between these numbers, we have a transition area. So, for example, when the velocity of a flow increases, we tend to go from a laminar flow to a turbulent flow with a larger Reynolds number. When we increase the viscosity of the fluid, as for example in cases of debris flow or lava flow, we tend to have a laminar flow with a smaller Reynolds number. On the other hand, let's consider air. We know that air is a fluid with very low viscosity, so it will always carry particles in a turbulent way. Now, water flow is laminar only when the flow has very low velocity or when water is flowing in shallow depths. These turbulent flows more commonly participate in sediment transport and deposition processes than laminar flows. In fact, turbulent flows of water and air are the most capable of carrying sediments because the turbulence increases the efficiency of the masses of fluid in eroding and entraining particles from the bed above which the flow is occurring. The last important parameter that is important for us to know with respect to how fluids transport the sediments is the flow number. This number is a dimensionless quantity representing the ratio of the mean velocity of flow to the velocity of the waves in shallow water flow. The flow number can be interpreted as the ratio of the inertial forces to the gravity forces in the flow. In simple terms, it is a parameter that quantifies how gravity influences the way in which a flowing fluid transmits surface waves, which is an indicator of whether the flow will be tranquil or subcritical with flow number lower than 1, or if it's going to be shooting or supercritical with flow number higher than 1. In a tranquil flow, the speed of the waves will be greater than the velocity of the stream. The way to visualize this is to think of a very tranquil stream of water like the one in the left. If you throw a little pebble into this tranquil stream, the waves created by the impact will probably be able to propagate against the current upstream. In this case, the stream will have a flow number lower than 1. Now, if you throw that same pebble into a shooting flow of water, like the one on the right, with a flow number greater than 1, the waves will not be able to travel upstream because the velocity of the stream becomes greater than the speed at which the waves move. For instance, a transition from lower to higher flow numbers may occur when a tranquil flow moving over a relatively flat surface turns into a shooting flow moving over a steep slope. Now, the flow number is important for us because it is an indicator of the flow regimes in which bedding occurs. This is because a flow number of around 1 marks the transition between the lower flow regime and the upper flow regime. And in a lower flow regime with a flow number lower than 1, we have the conditions that generate ripples and dunes. Whereas in a higher flow regime with a flow number higher than 1, we have the conditions that generate flat bedding, antidunes, and shoots and pools.